That's all bad. But it's not all about the average temperature in a region or the average aridity in the region. That doesn't really matter so much to us. I mean, if the average temperature of Europe goes up 2 degrees, I don't think anyone would actually notice. Okay? If you go outside and it's like 14 degrees or 16 degrees, you know, not such a big deal. What is a big deal is these extremes of climate. Okay, so we've got, so this is kind of the up here. We've got the, this is the effects of Hurricane Sandy, North America there. There's a heat wave in Paris and over most of Europe. Apparently this summer, but I didn't notice that. Flooding events. This is recently in Indonesia, I think, some flooding, and obviously droughts as well. So basically, when you have an event that's much wetter or much drier than usual for the year, that's when basically the infrastructure of kind of human existence starts to not be able to cope. Okay, if it's always kind of going to be warm, if every day is going to be warmer, then it's very easy to adapt to that. But if there's kind of sudden extremes of climate or extremes of weather, that's when most economic damage is done. That's when most people die. Okay, so this is an example from this year. So this heat wave. Okay, so it was only, well, it was up to 5 degrees warmer than a normal July. Okay, and that killed 700 French pensioners, many more hospitalised. It was a big deal. Okay. So if we start to think about these in a kind of a slightly more statistical way, so if you just imagine that example of a heat wave. Okay, so if you imagine in July, in any one year, the hottest, or the average, if you just take a heat wave would be 5 hot days in a row. Okay, so if you look at every year that has happened so far, and you look in July and you say, what are the 5? The average of the 5 hottest days, okay, and you make a number for that, figure out that number for every year, okay. Every year on average will be around some mean value, okay, and sometimes the hottest 5 days in July will be a little bit cooler than the year before. Sometimes they'll be a little bit warmer, okay. But the tendency will be for them to be around the average 5 hottest day in July for any one given year. Okay. Now, if you look at, you'll get a distribution if you do measure lots of different years of something that looks like this, where you're more likely to have something around the average, and it's actually very unlikely for you to have anything that's kind of an extreme cold July or an extreme hot July. Okay. But it's these rare events that only happen frequently. So out here, maybe 2 standard deviations of the variability. It's maybe like 4 in 100 chance. So every 100 years, you might get 4 events that are hot enough to kill 1,000 pensioners. Okay? So we've got to think about what happens if we shift the average state of the climate. Okay? So if we make the climate just a little bit warmer, but keep the same variability, okay, that's what's happening up here. Okay, so this might have been our original distribution, and it's very unlikely that we get down into this region here and happen to have a year where July is really hot and kills lots of people. Okay, but if we just shift the whole distribution, the whole average temperature warmer, okay, that means we have the same variability. So one year might be a bit colder, one year might be a bit warmer. But the likelihood of us exceeding this temperature here for 5 days in a row, whatever it is now a much bigger slice of the pie. Okay? So we've basically increased the likelihood of having an extreme event. Okay? And we've also added the possibility of having a small possibility of having an event that's even hotter than we would have ever expected before. Okay? So we're basically making extreme events more likely, and also more likely to be more extreme, just by shifting the distribution of probability of there being kind of the hottest day of the year. So this could be for any kind of extreme event. Okay, so it could be the windiest day, it could be the wettest 12-hour period. Okay, usually the wettest 12-hour period of year would be around some average for any one year. But as we make the climate wetter, overall, the probability of getting one of these really extreme events starts to go up quite a lot. So it's not just shifting the mean. If we basically make the climate more variable, if we make our weather more unpredictable, okay, this distribution kind of gets wider, okay, as it becomes less certain that any one day will be more like the mean for that time of year. Okay, so if you make the distribution wider, you also increase the probability of getting these extreme events. Okay, so this is happening to the climate system. So if you do both of these things, obviously it gets much, much worse. Okay, so these next graphs are quite hard to comprehend, but they're basically taking that idea of shifting the probability, okay, and basically trying to quantify how much more likely is it for a certain event to happen. So if you look at the one on the left, so this is the time, okay, so this is going into the future, 100 years into the future. And it's basically warm days. So this is basically saying, what's the probability that we will have an extremely warm day? Okay, it's probably got some more specific definition, like what's the probability of having 5 days in a row that are kind of at the top 10% of warm days, using our the weather over the last 50 years as an average. And you can see over this period there is a 10% chance. So this is 10, 20, 30, 40, 10% chance that we'll have a warm day that is in the top 10% of warm days. Okay? It's kind of satisfying kind of like a statement there. Okay? But as the climate warms into the future using different emission scenarios, okay, the likelihood or the likelihood of us of exceeding that temperature of the 10% warm days from the 60s or so, okay, we're much more likely now. So at the end of the century, okay, let's pick even if we're kind of like good boys and girls and we stop burning our CO2, it will be the probability of us having a set of warm days that was at maybe 10%, so one every 10 years, will now be 30%. Okay, and if we do nothing, we do nothing. When I say nothing, we carry on burning fossil fuels, we get to kind of 60%. So that's almost kind of every other year we're going to have a nasty heat wave. Okay? So you can think of it in terms of the likelihood of the likelihood of a hot event happening, or you could also, the graph on the right is the similar kind of argument, but instead of looking at what's the likelihood of an event above some certain threshold happening, it's basically looking at what is the most extreme event that happens in any one year. Okay, so it's basically looking at what is the wettest day. Okay, and as you go through time, we start to get more and more wetter as we go through time. So we can basically do this exercise around the globe and make a map of what is the likely kind of change in the likelihood of something happening. That doesn't really make sense. We want a big one here. So this is basically a map of the return period. So this is basically saying, if we consider a 20-year event, so this is basically the wettest day every 20 years. So if you think back through your entire lives and think about what is the wettest day you can remember, okay? And then what this map is showing is how the frequency of that wet day, how is that likely to change? So you can see over in kind of like Africa here, okay, it stays around 20 years, maybe a bit more. Okay? So it means that we're not going to expect it to be getting kind of those extreme 20-year. So basically, the likelihood of there being a 20-year, once every 20-year flood that will stay the same. But if you look up here in Scotland, okay, we're getting to these blues and these greens, so that's turning into more of a 5 to 7 year return period. So that means that that extreme flooding event that might happen over Scotland, instead of happening once every 20 years on average, is going to happen more like once every 5 or 6 years. Okay? So we're just increasing the likelihood of hazardous stuff going on. Okay, so and these are kind of like a summary of those changes. So, you know, heavy precipitation events, okay, are likely to increase. You can read through that in your own time.